In this video, I'm going to begin configuring the hydraulic prototypes for catch basins. So I'm inside of my drainage DG and lib, and I've opened up the prototypes dialog, and I'm going to start creating new prototypes. I'm going to create one for each one of my different types of inlets. So I'll go ahead and rename my first one, and then I'll come over here and start filling out my properties. Now I've already collapsed the areas that I don't need to configure for the prototype. Remember, what we're doing with the prototype is we're setting those initial hydraulic settings. So we want to set these in a way that are going to fit most purposes, and then after placement of these nodes or per project, these could be changed as needed. Starting with the design section, this is all going to have to do with when I'm running a design scenario. I'm going to leave local pipe matching constraints set to false. I'm also going to have the local inlet constraints set to false. During a design, I do want the structure elevation to be designed, so I'll set that to true. For the desired sump depth, I'm going to leave that at 0. As I can see from the drawing, there is not a default sump depth defined here. The sump depth is going to be the distance below the lowest pipe invert and the bottom of the structure. So during a design, if they do want to apply a sump depth, they could enter that in there, but by default, I'm going to leave that at 0. The conduit cover at the node minimum and maximum, I'll also leave those at 0, and instead I'm going to rely on what I have defined for the gravity pipes here in the cover tab. And then on the node tab, I'm going to make sure that I have the use node cover constraints set off. The freeboard required, that's going to be the depth below the rim elevation used to specify if I'm overflowing. So that's going to be 1 foot below the rim elevation. So that's just going to, you're going to need to talk to the drainage team and see what they use for that. And then I am going to leave design inlet opening true. Now if I take a look at my inlet catalog, I don't have any of those defined, so that means that even though I have this set to true, I'm not going to be designing any of my inlet openings. However, by having it set to true, I will be able to specify local inlet constraints as I need to. So the way that this toggle is used, if we're doing an inlet and sag, the length is going to be automatically selected, and it's going to start at the smallest available length to the largest to generate a certain spread in depth at the curb that's going to be less than the maximums that are specified. And then if we're looking at an inlet on grade, that inlet length is going to be selected again by the smallest first and then move to the larger one to generate an inlet efficiency that's larger than the minimum that's been specified. And that's all going to come from the default design constraints here for an inlet. So there's the maximum spread and gutter depth, and then there's the minimum efficiency. Moving down to the inlet type, we're going to set this to a catalog inlet. And I've already set up my inlet catalog, so that's going to be a 2 by 3 foot type B with type B frame and grate. For the inlet location, we have two choices here. We can do in sag or on grade. And the majority of these inlets are going to be placed on grade. So I'll go ahead and set that, and then after placement, if it is an in sag inlet, that could be changed. The mannings in here is going to refer to the roughness factor for the roadway to be used for the spread and gutter depth calculations. So you'll want to make sure you set that correctly. And then for the longitudinal slope, I'm going to leave that as the default value, as this is either going to be calculated by the software by pulling the longitudinal slope from the terrain model, or it's going to be manually entered in per project by the designer. So that's not something that I'm going to set up in the prototype. The grate length and the curb opening are both being pulled from my inlet catalog, so I don't need to set anything there. And then for the clogging factor, this is going to be used to reduce the effective area of the grate, and it works differently for on-sag or on-grade catch basins. But if we're thinking about on-grade catch basins, the clogging factor is going to impact the flow downstream of the catch basin. This is because not all of the capture efficiency will be decreased, and that's going to result in changes in the flow for the downstream conduit and any gutter flow that might be there as well. If we're looking at an in-sag inlet, the catch basin is assumed already to capture 100% of the flow, and for that reason, the clogging factor will not impact the downstream flow. Since all the flows is going to be captured, the flow will be the same regardless of the value used for your clogging factor. However, the gutter depth reported at the catch basin will be different. So typically this is something that's going to be set per project and not on the prototype level, but if you do have a default clogging factor you want to apply to a certain inlet, then you would put that in there.